Hello students, today we will see the next topic, that is static characteristic of common base configuration. So in order to study the common base configuration, we will take into consideration the NPN transistor, and as we are seeing the common base configuration, so in case of common base configuration, base terminal is common to input as well as output. So first we will see the circuit diagram for the common base configuration. So for common base configuration, as we are seeing NPN transistor, this is a N terminal which is a emitter, this is a base which is a P type, this is a base, and this is collector terminal which is again N type. So for this transistor will work in active mode, that is emitter base portion is in forward bias while base collector portion is in reverse bias. So in order to work the transistor in active mode, emitter base terminal is in forward bias while base terminal is in reverse bias, and as this emitter is the N-type semiconductor, so in order to work this emitter base in forward bias, the negative terminal of the battery is connected to the emitter. So this negative terminal is connected to the emitter and positive terminal is connected to the base. So this is the input portion for this common base configuration, and this is the direction of current IE and this is the direction of current IB. To the both, that is the input as well as output circuit, the milliammeter is connected in order to observe the input as well as output current in series, and millivoltmeter is connected in parallel to observe the input as well as output voltages. this figure shows the circuit diagram for the static characteristic of common base configuration. So there are two types of static characteristic for the common base configuration. First one is input characteristic and other one is output characteristic. So as this is a direction of emitter current IE, this is the direction of base current IB, and this is direction for collector current IC, and this voltmeter will measure the voltage between emitter and base terminal. So this voltmeter will give the input voltage and this millimeter will give the input current. So the input characteristic is nothing but it is the plot of emitter current versus the emitter base voltage at constant collector base voltage. So at this when collector base voltage is kept constant, one has to observe the change in IE as a function of VEB. So this voltage will be, the voltage between emitter and base will be VEB, and the voltage between this collector terminal and base terminal will be VCB. So we will see the input characteristic. Input characteristics. So IE is plotted at y-axis and VEB is plotted along x-axis. Emitter base voltage VEB along x-axis, and here is the emitter current. I will write here emitter current IE along the y-axis. So emitter current is measured in terms of milliampere. Here it will be measured in terms of milliampere, and emitter base voltage in terms of millivolt. So in order to observe the variation in IE as a function of VEB, VCB is kept constant. So let initially VCB is 0 volt. and so when VCB is 0 volt, this is the variation of IE as a function of VEB. VCB is 0 volt, and when this VCB is slightly increased, that is from 0 volt to 10 volt, then this is the nature. So this is for VCB equal to 10 volt. So it is observed that from input characteristic, IE increases rapidly with small increase in emitter base voltage VEB. That is for this input characteristic, as IE increases rapidly with small change in VEB, the input resistance for this circuit for the input characteristic is very small. Then next point, one should note that emitter current IE is independent of collector base voltage VCB, that is IE as well as IC, that is emitter current as well as collector current is almost independent of collector voltage, that is this VCB. IE as well as IC is independent of this VCB. So from this one has to take into consideration the entity, that is input resistance. Input resistance. So input resistance is nothing but small change in emitter base voltage as a function of emitter current. So this input resistance Ri is given by delta VEB by delta IE at constant VCB, at constant VCB. So this is the input resistance of the common base configuration, which is very small. Then next one has to study the output characteristic, that is the variation in collector current as a function of collector base voltage at constant IE, that is emitter current. When this IE is kept constant, what is the variation in IC as a function of VCB? So we will discuss this output characteristic. Next is output characteristics. So in order to observe the output characteristic, one should note the variation in IC, that is collector current as a function of collector base voltage. So here at y-axis one should plot the collector current IC, which is measured in terms of milliampere and as a function of collector base voltage. Collector base voltage. VCB, which is measured in terms of millivolt. So as I is kept constant, one should observe when IE is equal to 0 milliampere, IE is equal to 1 milliampere, IE is equal to 2 milliampere, IE is equal to 3 milliampere, IE is equal to 4 milliampere and IE is equal to 5 milliampere. So from this output characteristic one should note some points, that is collector current IC varies with VCB only at low voltages, that is when the voltage, that is VCB, is less than 1 volt. The transistor is never operated in this region when VCB is less than 1 volt. When the value of VCB is raised above 1 to 2 volt, the collector current IC becomes constant as indicated by the straight horizontal curves in this figure. All the IC, that is variation in IC as a function of VCB, shows the straight horizontal curves. IC is independent of VCB and depends upon IE, that is emitter current only. The transistor is always operated in this region. Then next point one has to consider is a very large change in collector base voltage produces only small change in collector current. Very large change in VCB produces only small current in IC. So output resistance is very high. So this output characteristics introduces the entity, that is output resistance. Output resistance. So output resistance of the common base configuration is nothing but it is the change in collector collector base voltage with respect to change in collector current at constant emitter current. So this output resistance is given by R0 is equal to delta VCB by delta IC at constant IE, at constant IE. So these are the output characteristic of common base configuration, and with this I will stop here. Thank you.